Hello everyone. Hello. All right. Now let's solve this electromagnetic wave question. All right. So in this video, okay, we'll be looking at how to show that the angle between the reflected ray and the refracted ray, that is, this is the reflected ray and the refracted ray, which is what we have here as theta, why it is equals to 90 degrees. All right, so we have a narrow beam of unpolarized light, okay, is incident at the boundary between air and glass. So which means light passes from air into glass. So we have the first medium to be air, and then we have the second medium to be what? Glass. So when light is transmitted obliquely through the boundary separating air and glass, okay, now the refracted ray, which that is the ray which emerge, also known as the transmitted ray, okay, and then we also have the reflected ray. When the light is incident on the boundary, when it is incident on the boundary surface, now it's what? Part of the light is reflected and part of the light is what? Refracted. So the angle between the reflected ray and the refracted ray, we want to show why this angle is equal to 90 degrees. So also we are given the refractive index of air to be 1.0. So which means since the first medium is air, so we have the refractive index of air to be 1.00. Okay, and then the refractive index of the glass to be 1.5. So we have the refractive index of glass to be 1.50. Now we have the angle of the angle of incidence of the light, so which means is 56.3 degrees. So which means the light ray, okay, the incident ray makes angle 56.3 degrees. That's 56.3 degrees with the normal, okay? So then we want to show that the angle between, that's angle theta, between the refracted ray in the glass and the reflected ray in the air. We want to show that it is equals to 90 degrees. Okay, we want to show that it is equals to 90 degrees. So this is 90 degrees. All right, so now in this case, we need to first identify the values that we're given. All right, so we are given the angle of incidence, which is the incident angle, the angle of incidence. Let's say the angle of incidence is theta 1, okay, theta 1, and the angle of incidence is 50, that's 56.3 degrees, okay. Then also we're not giving the angle of refraction, so we need the angle of refraction, which is theta 2. All right, so now the angle of refraction is the angle which the refracted ray or the transmitted ray makes with the normal, and that's what we have here as theta 2. Okay, so we need to find out what is the value of theta 2. All right, then we're also given the index of refraction in air. Okay, index of refraction of air, all right, which is n air. That will be equals to 1.00. Then also we have the index of refraction. We have the index of refraction of glass, okay, which is n glass. That's 1.50. All right. Now, to be able to calculate the value of theta 2, so it means we are going to apply what we call the Snell's law. So to apply the Snell's law formula, okay, so let's set up the equation for Snell's law, which is the product of the index of refraction in air, which is the first medium, and the sine of angle of incidence, okay, the incident angle, equals to the product of index of refraction in glass and the what? And the sine of angle of refraction. So now let's rearrange this equation, so that we can calculate the value of theta 2. So sine of angle of refraction will be equals to index of refraction in air multiplied by the sine of angle of incidence over what? Sine of angle of that's over refractive index in glass, index of refraction. Okay, so which means this will be the sine inverse, which is the inverse sine of the index of refraction of air is 1.0, then that will be multiplied by sine of angle of incidence, and we have the angle of incidence to be 56.3 divided by the index of refraction in glass, which is 1.50. Okay, so that the angle of refraction would be what we get from what is the inverse sine of sine 56.3 divided by 1.5. Okay, so let's get what is sine 56.3. Now sine 56.3 is 0.83195. Okay, so we have the inverse sine of 0.83195. Okay, divide by 1.5. Divide by 1.5. Okay, so divide by 1.5, that would be 0.5546. So we then have the angle of refraction to be the inverse sine of 0.5546. 0.5546. All right, so the sine inverse of 0.5546, that will be 33.68. So the angle of refraction is 33.68. Okay, so this is our angle of refraction. This is the angle of refraction. This is the angle of refraction. Okay, now we just calculated the value of theta 2, which is angle of refraction. Now, we also, now it is important for us to know that the incident angle, which makes, that's the incident angle, which is 56.3, okay, is also equal to the reflected angle. That is, angle of incidence is equal to angle of reflection. That is according to Snell's law of regular reflection. Now we know that angle of incidence, okay, angle of incidence is equal to angle of reflection. So that's important, which is according to what? Snell's law of regular or specular reflection. Snell's law of regular or specular reflection. So which means the reflected angle, this angle of reflection in this case will be 56.3 degrees. Now we just found the angle of what? Angle of refraction. That is the angle which the refracted ray makes with the normal. That's what we call angle of refraction. So when we know the value of this guy, okay, theta 2, so it means we can then find out what is the value of theta. So to be able to calculate the value of theta, so what we have here is more like we have a straight line, then we have these three angles. We have these three angles, okay? So let's say this is the reflected ray, and the reflected ray makes angle 56.3 degrees, okay? Then we have the refracted ray. So the angle which the refracted ray makes with the normal, this is the normal. This is the normal. The angle which the refracted ray makes with the normal is now what we calculated here to be 33.68. Okay, so we are looking for the angle between, this is a refracted ray, okay, we have the refracted ray, and then we also have the what? The reflected ray. So this is the boundary, okay, but the angle between the refracted and the reflected ray is what we are looking for. So this is on a straight line, so we can just say that this is we're going to have 56.3 degrees plus 33.68 plus theta equals to 180 degrees. 180 degrees. That's on a straight line. So let's get the value of, so what is 56.3 added to 33.68? Okay, that will be 89.98. So we have theta to be 89.98 equals to 180 degrees. So that theta would be 180 negative 89.98. Okay, so what is 180 minus 89.98? Now that will be 90.02. So theta equals to 90.02 0.02. So which means theta will be approximately 90, that is 9.0 what degrees. And this is the angle, this is the what? The angle between the reflected ray and the what? Refracted ray. The noblest pleasure is the joy of understanding. Bye bye.